Next thing we're going to do is we're going to talk about the unit circle definitions of the 6 trig functions. A unit circle is a circle that is centered at the origin with a radius of 1. So I use my trig of any angle definitions, and I just replace everywhere there was an r, I replace it with the number 1. So these are my unit circle definitions. So sine was y over r, so that just becomes the y coordinate. Cosine was x over r, so that becomes the x coordinate. Then I have y over x, where x is not equal to 0. Cosecant's the reciprocal, so that would be 1 over y not equal 0. Secant would be 1 over x, where x is not equal to 0. And tangent would be x over y, where y is not equal to 0. So these should be the last 6 trig definitions that you have to fill out on your benchmark test sheet. So what we're going to do is we are going to come up with the exact values of the trig functions on the unit circle. And the ones you have to have memorized are the multiples of 30 degrees, 45 degrees, and 60 degrees. And you're going to see a pattern here. And there is a shortcut to coming up with all of the answers on this circle. Okay, and the shortcut is the following relationship. Square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, and the square root of 4 over 2. These are the numbers that we're going to fill in everywhere for these coordinates. We're going to simplify these. Well, what's the square root of 0? 0. 0 over 2 is 0. Square root of 1 over 2 is 1/2. Square root of 2 over 2 does not simplify. Square root of 3 over 2 does not simplify. Square root of 4 over 2 is 2 over 2, which is 1. So these are the 5 different numbers that I use to fill out everywhere on this sheet. And notice they are small to large. And here's where you want to use the unit circle definitions. Unit circle definitions is that the sine is the y coordinate. So if I have an angle that's like this, I have a short x coordinate and a long y coordinate. If it's 45 degrees, the x and the y are the same. These are the shorter numbers. These are the longer numbers. So if you know where the quadrantal points are on the unit circle, 1, 0, 0, 1, negative 1, 0, and 0, negative 1, you're either going to increase or decrease in this order to fill out your blanks. So from 0 going to 1 for my y coordinates, I just follow this pattern. 1/2, square root of 2 over 2, square root of 3 over 2. Then 1, and then back down to 0. Notice, square root of 3, square root of 2, 1/2, and 0. Square root of 3 over 2, square root of 2 over 2, 1/2, 0. 1/2, square root of 2 over 2, square root of 3 over 2, 1. Square root of 3 over 2, square root of 2 over 2, 1/2. Now the only thing that I need to do now is I need to figure out the SIG and sine of all of these. And I'm doing y coordinates, so all my y coordinates are positive in quadrants 1 or 2, and they are negative in quadrants 3 and 4. So let's look at the cosines. Cosines are the x-coordinates. My x-coordinates are going from 1 to 0. So I'm going to go from 1 to 0 this way. And I get the square root of 3 over 2, square root of 2 over 2, 1/2, 1/2, square root of 2 over 2, square root of 3 over 2, 1, square root of 3 over 2, square root of 2 over 2, 1/2, 1/2, square root of 2 over 2, square root of 3 over 2. Next thing I need to do is check my SIG and sines of the x-coordinates. X's are positive here, so those are all good. They're negative in quadrants 2 and 3, so change these to negatives. Okay, this is where I use my arm to figure out these values. I figure out where my arm is, and is x short or the long side. Okay, if you notice here, the square root of 2 over 2's always go together. And then you always have a 1/2 paired with the square root of 3 over 2. 1/2 is small. So if you end up making your arm where you have the x is small and the y is big, that would be the square root of 3 over 2, and that would be the 1/2 side. So cosine would be 1/2, sine would be the square root of 3 over 2. Notice that is this angle. And if you notice the way I drew it on the board, all of your pi third angles have the same numbers with the exception of the SIG and sine. Same thing with the pi sixth angles. They're all the same numbers with the exception of the SIG and sine. Same thing with the pi fourth angles and the quadrantal angles. So I expect these to be memorized. You will have to complete the unit circle the day before your end of chapter test, and that will be part of your test grade. So you need to be able to use this. So I'm going to pause the video. I'm going to erase this work on the bottom, and I'm going to set up to do some example problems. So the way I'm going to do these example problems is I'm going to actually just use my arm to draw the angle. Okay? Because I'm facing you, I'm doing it backwards from the way I would actually see it. But I use my arm and I figure out where I am, whether x or y is the long side or the short side, depending upon my angle. So tangent is 240 degrees. So I start over here. So 0, 90, 180. 180 plus 60 is 240 degrees. So it's a quadrant 3 angle where the x is short and the y is long. X is short, y is long. Okay, it's quadrant 3, so they're both negative, and I want the tangent. So the tangent is going to be y over x, so it's the square root of 3. Now let me look at my unit circle. 240 degrees, I got those same numbers. So I use my arm to come up with the numbers every time. Am I short or long, or are they the same size? Then I use that for my relationships. I write down that coordinate, and then I figure it out. So 17 pi 6. So I start out here at 0. 6 pi 6 is pi. So that's 6, 12, okay, 13, 14, 15, 16, 17 pi 6. So that's what my angle looks like. The y is short, the x is long. The y is short, the x is long. I am in quadrant 2, so y's are positive, x's are negative, and my sine is going to be the y coordinate, or 1/2. The last one is negative 5 pi thirds. So I start here rotating the other direction. So this would be negative 1/3, negative 2/3, negative 3/3, negative 4/3, negative 5/3. I've got a quadrant 1 angle. So my quadrant 1 angle looks like this. The x's are short, the y's are long. The x's are short, the y's are long. I want the cosine. Cosine is the x coordinate, so it is 1/2. So that's the way I want you to go about finding the trig functions using the unit circle. And the only ones you are going to go about finding on the unit circle are those that are coterminal to these memorized angles. Last thing I want to talk about is I want to talk about a reference angle. I'm going to use these three right here to come up with the reference angles. So a reference angle is the angle between the x-axis and the terminal side. So let me draw this. So 240 degrees is 90, 180, 240. This angle right here, I'm going to call it alpha, is the reference angle. Well, that reference angle is 60 degrees. It's how much between the x-axis and the terminal side. And if you notice, I get the same numbers here that I had here. So the reference angles have the same numbers of where your angles are going to lie in here. Okay? And again, I only think about how to get the first quadrant numbers, and then I just think, is it short or tall or the same distance? Okay, reference angle for 17 pi 6. 6, 12 plus 5 more 6. Well, this is the angle I want. So if this is 5 pi 6, this would be 1 pi 6. And now you can see why I drew these things in different colors. The reference angle for 150 degrees is the quadrant 1 30-degree angle. The reference angle for 315 degrees is the quadrant 1 45-degree angle. Let's do this one. Negative 5 pi thirds. Negative 1/3, 2/3, 3/3, 4/3, 5/3. If it's negative 5 pi thirds, well, 6 pi thirds is all the way, so this one would be pi thirds. And notice that's where I got that answer from. So again, be able to find reference angles, and then just use where does my arm lie to figure out, am I short or long? This here, x's are long, y's are short, so that would be 1/2 square root of 3 over 2. Down here, x's are short, y's are long, negative 1/2, negative square root of 3 over 2. Okay, use that. All students take calculus to remember whether the signs are positive, sines, cosines, and tangents are positive or negative, or just use the relationship if you know where the x's and y's are positive or negative to come up with your answers. That's it for 9-3.